Okay, for example 3, it says find the local minimum and maximum values of the function f in example 2. Okay, recall the first derivative test tells us that suppose that c is a critical number of a continuous function f. Well, we know that -1, 0, and 2 are critical numbers. If f prime changes from positive to negative at c, then f has a local maximum at c. So that means that if we have a derivative going from positive to negative, then it's going to be a local maximum. So do we have anything going from positive to negative? Well, we can see that this represents the going from positive to negative, and we can see that 0 is a critical number, which tells us that 0 represents a local maximum. Okay, and then we can also look at the next part, and so that tells us that if the derivative changes from negative to positive at c, then f has a local minimum at c. So here we're going from negative to positive, and we're also going from negative to positive here. So what does that tell us? Well, that tells us that this critical number represents a local minimum, and that this number also represents a local minimum. So what that means is we have a local minimum at x is equal to -1 and +2, and we have a local maximum at x is equal to 0. And again, we can confirm this on our graph, right? This is our graph. We can see that this represents a local minimum at -1, and then we also have a local minimum at 2. And then here we can see that we have a local maximum at 0. But again, this is the test that's telling us, so we want to know what happens with the derivative. So if this derivative changes to signs, then it tells us what the local minimum and maximum is.